Hi everyone, I'm Veer Satya. I'll discuss about the high-level design for MQTT firmware development in this video. The project plan and the software requirement documents, right, are given in a different video. I'll just provide the description of this video. So we'll just start with the software requirement specification. Okay. Just okay. We'll just require start with the system architecture. So in the system architecture, you'll give the core architecture components. So basically about the client module, then encryption, TLS encryption module, and power management module and the integration layer. So then you will have the system flow. In the system flow, you'll start with the initialization. So how do you start the device, right? The code will be there in this particular functions. And what are the are to be initialized here for effective system utilization? Establish network connectivity. You need to establish the connectivity between your device and AWS service. Initialize MQTT client with necessary credentials. So initialization of the client with the config parameters. So normally here that the config file will be read and the MQTT client will be initialized. Then you will have the MQTT connection. So here you will have the secure connection between using the MQTT AIT core. Then TLS encryption there. So here you will have the TLS handshaking mechanism which will be established. Subscription and data handling. Subscribe to. So how do you subscribe to a particular MQTT topic, right? Will be identified here, and all the incoming messages, right? Whatever data you're getting, that has to be stored, right? So all that aspects here are given here. Then you need to publish, right, the sensor data and the device status, right, to AWS IoT core. So whatever changes in the sensor data, right, so every time it will read and it will be sending to the IoT core. So then the low power mode, so monitor device activity, enter low power mode. So when the device is inactive, right, it will go to the low power mode. And when there is a device activity, right, device activity, the wake up of the and the synchronization of the data will come when activity resumes. And you will have the disconnection as right. So all the memory which has been initialized, right, that should be deallocated when you are disconnecting from AWS IoT core. And synchronization between entering deep and sleep and shutdown. So synchronization. So here you'll have the module design. So these are the functions. You'll have the MQTT connect subscription. So establish here you'll give the connection establishment, then subscription. So when you are subscribing to topics, then MQTT publish. So whatever tail topic, right, disconnect. And here you will have dependencies, right? Before this gets established, there'll be some dependencies related to network connectivity and AWS IoT credentials. So that part, right, should be established there. Then TLS encryption module. The functions will be like TLS in key init and TLI handshake. The handshaking mechanism will be done in this function. Then you will have the encryption on outgoing data. So whatever data is going out, right, that will be encrypted with the key. Similarly, decryption also will happen. So, and the dependencies will be the libraries, TLS and SSL libraries, and the storage of certificate and keys. Then you'll have the power management module. So enter low power mode. So just these are the different modules. I'll just go through the architecture diagram which I have given in a different document. Just a moment. Yeah, this is so this is a block diagram, the architecture document. So where you will have the main controller, right, and the communication with the hardware abstraction layer, and you will have the MQTT communication. So the main logic, right, of the complete firmware, right, will be here, and your diagnostics and logging component. The power management will be here, and the config module, right, where you'll have this JSON files, right, will be here, and the TLS section. So we'll also discuss a document also. So these are the different modules. So power management modules. So enter low power mode. So this is the entering of the low power mode function. Then wake up from sleep. So when you there is an activity, right, there will be a wake up from the sleep mode. So that should be do. And manage power, right. And this is a monitoring mechanism which will be managed. Then dependencies will be hardware support for low power. So even if you have the software code, right, established, even the hardware, right, to should be done at the layer 1 and layer 2. So accurate wake up and the integration. So these are the till Python SDK integration, right, where you will utilize all the quick Python API Python. So here, so using quick Python init and exec commands executes within the handle API calls. So where you'll handle the quick Python libraries. So then dependencies and milestones. So here you will have the requirement confirmation and design. So some QI slabs, right, will be the deliverables here. Then project prototype. So it's better, right? There are different aspects when you want to design. Some people will go by a prototype method. You'll develop a prototype firmware which minimum functionalities, then you'll add feature by feature after you develop a. So the other aspect is agile methodology, where segregate the complete firmware into different features. So each feature will be added. So every day, every time, right, there will be a build system which will generate the firmware. So every time there will be a testing. So you'll have the DevOps mechanism established here in this method. So there are two you can adopt based on your thing. So if the firmware is simple, right, I can go for simple prototyping and the simple method and adding the features. So if the firmware is complex, it's better to go for agile methodology. So it's better mechanism, agile methodology. Then the feature enhancement. Suppose if you want to add some features, right, so we can add here listed. And deployment on optimization. You need to have a deployment, right, how you deployed on different hardware devices. So these are set of project deliverables: complete firmware code, documentation, testing reports, so user manual and developer guide, right. So this will be part of the high level design document. So we'll just come to low level design document. Sorry. Usually in low level design document, you'll have the some additional functionalities, right? So this is almost same. So it will describe the components. Some pseudo code will be there. So you'll have the pseudo code here, initialization of the uh, code. Some code will be there here. So this is a code. So you can modify this of the code, right? Where overall broader level overview of the code is written here related to the client module. Then you need subscript topic, and so these are the different functions. Then you'll have the encryption TLS encryption module. So how are you loading the certificates, and the utilization of the TLS handshake is given here. And how are you sending the data here, right? So this is the different functions here. It's just a code. So you need to implement the code. And the project management module. So here power management. So this is more about low power mode here. Low power mode. Then you have how you wake up from sleep, right? How are you, and how are you managing the low power mode? And device driver module, initialization of the device, right? Our utilization of the GPIO pins, watch each pin is configured, is depicted here. And the locking mechanism also you can do it here. How are you reading the this is more pertaining to reading data from this data, right? From the I2C or SPA, which bus you are using, right? So based on that, similarly, writing data, right? Okay, then you have the configuration. So you need to take the configuration from the MQTT config file for all the config related parameters. Then you will have the configuration module. Then save device state folder structure. So this is the base folder structure what we can have. So SRC will have all the code related to the client module, to encryption module, power management device configuration file. Then you'll have the config, where you'll have the config file, certificate, and the device state, right? This will be there. And the libraries, the libraries in the library module, and docs, we'll have some documents and the test case, right? So in the tests, right, it will be there logs when you are loading some docs, right? For debugging, right, you need this logging folder where you will have the logging. So we'll just go to the firmware design doc. So where you'll have more details, right, pertaining to. So this I already discussed. So basically, right, these are the core modules. Basically, main controller module, right? So this is responsible for firmware logic and coordination between different modules. Then MQTT communication module. So where you will have the where you will manage MQTT communication with respect to AWS to server. So how do you communicate? How do you send the data? How do you receive the data? How do you authenticate the data? All these are here. Handle secure TLS security module. So this is more pertaining to the certificate and key exchange, right? All this here. And power management module, it's more pertaining to the low power mode. How you attain into the low power mode, how you come back from the wake state, right? Wake up state, right? The interface hardware abstraction module, right, is more pertaining to How do you interface with different sensors and actuators? How do you read the data, right? And here configuration module manages configuration between MQTT settings, TLS certificate, and power management. Diagnostics and login. So diagnostics is more pertaining to when you want to debug something, right? So you need some data, right? Diagnostics. So there you'll use the data for. There's a block diagram where the so this is a communication. So MQTT main controller, right? Will be communicating with the MQTT communication. Then you'll have the logging mechanism, and the abstract extraction will be communicating with the power management unit. Yes, the config will be communicating with the main controller. So TLS security is more you'll communicating with the MQTT communication. So basically, right, when you have multiple this things, so you'll have the state transition machine also. So there will be different states. So like initialization state where all the clients, right, will be initialized. Here AWS IoT integrations and the device. Then the state. So critical specific device configuration is configured and initialized here. Includes setting up of sensors and thing. Connect to the MQTT broker. This is a different where your connects, right, to start sending or receiving messages. Ideal or data read state. In this state, the system waits for sensor data or commands transition to read sensor data. So this is a transition state where reading or publishing the within next steps, even the flower here, right, will be the next state transition. Read sensor data and then send data to MQTT, AWS IOT. Publish data to MQTT broker, publish collect. Now the setups, right? Enter power save mode. So this is a wake up from power save mode, check from data, reinitialize. So these are the states. So based on your requirement, right, you can utilize one of the states. You can remove this one of the states as well. You can customize the states and you can come up with your own state machine. So accordingly, with the help of a state machine, right, you can implement the function. So here you have the module breakdown, where, so in case, right, initialize all the modules, right, to at startup and main. So and the loop will be initialized here. So here a main controller module will handle the reading of the sensor data, sending MQTT messages and entering. So this is a core module where all these tasks are done. So MQTT communication module. So this is more pertaining to what are the responsibilities and what are the so it's more like connecting between the MQTT client and the MQTT IoT core or AWS IoT core, and subscribing to topics and publish data. And also it handles errors. So what are the interfaces, right? That will be part interface data. Then you'll have the TLS security module. So initialization of the TLS and communication, right? And also a handshake mechanism for connection establishment. So here we have encryption and decryption interface with to provide secure channels. So there will be secure channels which will work power management module. So here these are the different steps, right, which are there as part of power management module. Monitor device activity and power states. Position the device into and out of low power mode. Hardware abstraction layer. It's more like providing a unified interface, right, for accessing the hardware components and reading the sensor data. Yeah, then you'll have the configuration module. So basically, you need to read the configuration, right, from for MQTT credentials. And, then I think we have already discussed the diagnostics and logging. So what is happens when they initially power on the initializing the configuration module, then you'll have the hardware abstraction layer, and then MQTT communication and the TLS and the main controller mode. So this is a sequence, right? When you power on the device, all these steps will happen. Okay, so main loop workflow. So what is that? So here, right, data acquisition. So main and controller module, right? So it will have this four states. That is data acquisition and reading sensor data from HAL and data transmission. You have to publish the data, right, to the AWS IOT core using MQTT and monitor data activity if inactive, and then event handling is also done here, respond to incoming messages. Then you'll have low power mode workflow and low power mode. So all the transitions, right, whether you switch back to low power mode and the wake up state, right, are done here. Then you'll have the hardware design deliverables, whatever you have, right, architecture module interface. So this is a code folder structure which I have already given, and it's already given in the previous slide. So then yeah, we haven't discussed. Okay, there are different sequence diagrams. So where, right, you should have even so initialize the MQTT client, then you will have set up TLS security, the MQTT client, right? So it will set up the TLS security module, establish TLS and connect to MQTT broker connection success. So these are the 5 different states, so that you can indicate with the sequence diagram. So these are the 3 different blocks: MQTT controller, MQTT client, and the TLS security. First step, right? So we'll go from MQTT controller to MQTT client to initialize the MQTT a client. So then it will set up TLS security. Then it will establish TLS security, then connect to MQTT broker and success. Then the data transition. So this is the different sequence diagram, how you read the data, publish data, and publish data to both to MQTT as well as to AWS. So here, right, you have MQTT controller module, MQTT client, and AWS IoT core. So these are the 3 components, right, where the data exchange will happen. The control messages. First is the MQTT controller will read the sensor data, publish to the client. Then you will have publish data to client. The data will be published. Response will be power state signals diagram. So in the power state changes, right, the main controller checks the device activity. If the device is inactive, then you will enter power state mode. If device is active again, then it will receives the signal and exit low power mode. So these are the different components: MQTT controller and the power management. Basically, first is it will monitor the device activity. If the device is inactive, then it will enter power save mode. Then fourth is device will active again, exit low power mode. The control will be exchanged. Then you will have, so these are the methods. It will be client module methods, right? Connect, disconnect, and for the MQTT client module. So these are the different function methods, right, for a client module. So subscribe and handling incoming messages. Similarly, for AWS IoT integration module, so you'll have this below methods. So initialize AWS IoT, initialize the connection with the AWS IoT code, send data to AWS IoT code, receive data from AWS IoT code. Then quick tell device module. So initialize, these are the different messages for the device, initialize device, read sensor data and code. So in configuration settings, right, there will be a config file, either it could be a JSON file or some other format where it will be read and set up. So in power management module, you'll have enter and exit low power modes. So based on the device activity, right? So this is the states dot JSON file. So every state, right, you can identify it by the device ID and current state, right? Last state, when are the last active state, and MQTT connection. So this will be there in a particular device, right? Power management, what is the state, and power save mode. So you can give the different states, MQTT configuration. So configuration. So you can broker address, right, will be there, and the port address will be there in here, and the client details and the topic. So all this, right, will be there in the JSON files. Okay, oh sorry. Okay, so this we have already discussed. So in case of event logs also, you can identify some of the format, right, how you want the event log, right? So different attributes and where different values, right? Okay. So these are the different states or mode, loop or mode. Okay, so this is the different states that you have: threshold, seconds. So sensor data will be there, events. So these are the different attributes. So all these different aspects of the complete design. So you need to, you can optimize and you can add more features, and you can also change some of the functionalities of the code, right, for your particular aspects. Thanks from IN.